The National Electrical Code, or NEC, Section 210.11. C1 states that small appliance, laundry, and bathroom branch circuits must be rated 20 amps. NEC Section 210.21. B3 states that no receptacle rated 15 amps shall supply a load exceeding 12 amps. An 1875-watt hairdryer typically draws 15.63 amps when connected to 120-volt supply. The NEC allows 15-amp devices on 20-amp circuits if the receptacle load does not exceed 80%. However, high-wattage appliances like hairdryers exceed the 12-amp limit for 15-amp receptacles. Using a 15-amp receptacle on a 20-amp circuit with a high-wattage appliance effectively limits the circuit capacity to 15 amps, potentially violating NEC Section 210.11. C1. Requiring 20-amp receptacles on 20-amp circuits in small appliance, laundry, and bathroom areas is a potential solution. This would allow high-wattage appliances to be used without exceeding the receptacle or circuit capacity. The proposed solution aligns with the NEC intent to provide adequate and safe electrical capacity. By requiring 20-amp receptacles on 20-amp circuits, it ensures that the entire 16-amp allowance of the circuit can be utilized without violating code requirements. While the installer may not have control over the end user's load, it is their responsibility to design and install circuits that meet code requirements and provide safe operation. In this case, using 20-amp receptacles is a simple and effective way to avoid potential code violations and safety concerns. It is recommended to install 20-amp receptacles on 20-amp rated circuits in small appliance, laundry, and bathroom areas to comply with NEC requirements and ensure safe operation of high-wattage appliances. Considerations exist regarding the application of 15-amp receptacles on 20-amp branch circuits, especially in locations like bathrooms, laundry rooms, and small appliance circuits where the NEC mandates the use of 20-amp rated circuits. Firstly, the NEC permits the installation of 15-amp receptacles on 20-amp branch circuits under certain conditions. Specifically, NEC Section 210.21. B3 allows this, provided that the total load connected to any single 15-amp receptacle does not exceed 12 amps, which is 80% of the receptacle's rating. Secondly, the issue arises when appliances with high wattage demands, such as an 1875-watt hairdryer, are plugged into these 15-amp receptacles on a 20-amp circuit. An 1875-watt hairdryer operating at 120 volts draws approximately 15.63 amps. This exceeds the 12-amp limit for a 15-amp receptacle. The implication is that the presence of a 15-amp receptacle on a 20-amp circuit, intended for use with appliances that may draw more than 12 amps, effectively reduces the usable capacity of the 20-amp circuit to the 15-amp rating of the receptacle. This can be seen as a potential violation of NEC Section 210.11. C1, which requires small appliance, laundry, and bathroom branch circuits to be rated at 20 amps. The argument is that if a 15-amp receptacle limits the circuit's capacity, the circuit no longer functions as a true 20-amp circuit, thus not meeting the code requirement. A proposed solution to this issue is to mandate the use of 20-amp receptacles on all 20-amp circuits in small appliance, laundry, and bathroom areas. This would allow for the full 16-amp capacity of the 20-amp circuit to be utilized without concern for exceeding the rating of the receptacle. The advantages of this approach include ensuring compliance with the NEC by maintaining the 20-amp capacity of the circuit and accommodating high-wattage appliances without creating a potential safety hazard. The responsibility of the installer is crucial in ensuring electrical safety and code compliance. While installers may not have control over the specific appliances used by end users, they are responsible for designing and installing circuits that meet the NEC requirements and provide a safe electrical system. Therefore, specifying 20-amp receptacles on 20-amp circuits in areas prone to high appliance usage is a proactive measure that can prevent potential code violations and enhance electrical safety. The recommendation is to implement a standard practice of installing 20-amp receptacles on 20-amp rated circuits in small appliance, laundry, and bathroom areas. This approach aligns with the NEC intent to provide sufficient electrical capacity and ensures the safe operation of high wattage appliances, thereby minimizing the risk of electrical hazards and code violations. Additional considerations for understanding the nuances of using 15 amp receptacles on 20 amp circuits under the NEC involve several key aspects of electrical safety and code compliance. Firstly, the specific wording and intent of NEC sections 210.11, C1 and 210.21, B3 are crucial. Section 210.11, C1 mandates that small appliance, laundry, and bathroom branch circuits must be rated at 20 amps. This requirement is intended to ensure that these circuits can handle the expected load for multiple appliances commonly used in these areas. Section 210.21, B3 allows 15 amp receptacles on 20 amp circuits, provided that the load on any individual 15 amp receptacle does not exceed 12 amps. The rationale behind this allowance is to provide flexibility in receptacle selection while still maintaining safety. Secondly, the practical implications of using high wattage appliances on these circuits must be considered. Appliances like hairdryers, curling irons, and toasters often have power ratings that exceed the 12 amp limit for 15 amp receptacles. When such appliances are plugged into a 15 amp receptacle on a 20 amp circuit, they can potentially overload the receptacle, even though the circuit breaker may not trip. This situation can lead to overheating of the receptacle and potentially create a fire hazard. Thirdly, the concept of continuous load is relevant. The NEC defines a continuous load as a load where the maximum current is expected to continue for 3 hours or more. For continuous loads, the overcurrent protection device, such as a circuit breaker, must be rated at not less than 125% of the continuous load. This requirement is in place to prevent nuisance tripping of circuit breakers due to sustained high current draw. Even if an appliance is not considered a continuous load, repeated use of high wattage appliances on a 15 amp receptacle can still create a cumulative heat buildup, increasing the risk of a thermal event. Fourthly, the role of the electrical installer is critical in ensuring compliance and safety. Installers must be knowledgeable about the NEC requirements and understand the potential implications of their design and installation choices. While they may not have direct control over the appliances used by the end user, they can influence the safety of the electrical system by selecting appropriate receptacles and wiring methods. Recommending or installing 20 amp receptacles on 20 amp circuits in areas prone to high appliance usage is a proactive step that can mitigate potential risks. Fifthly, the long-term reliability and safety of the electrical system should be considered. Over time, repeated overloading of 15 amp receptacles can degrade their performance and increase the risk of failure. By using 20 amp receptacles, the electrical system can better withstand the demands of modern appliances and provide a more reliable and safer electrical supply. Sixthly, the NEC includes provisions for ground fault circuit interrupter, or GFCI, protection in certain locations, such as bathrooms and kitchens. GFCI protection is designed to protect against electrical shock hazards by detecting ground faults and quickly interrupting the circuit. While GFCI protection is essential for safety, it does not address the issue of overloading receptacles. Therefore, even with GFCI protection, it is still important to ensure that receptacles are appropriately rated for the expected load. Seventhly, the use of arc fault circuit interrupter, or SI, protection is also relevant. SI protection is designed to detect arc faults, which are a common cause of electrical fires. SI breakers can help prevent fires caused by damaged wiring or loose connections. While SI protection is valuable, it does not eliminate the need for appropriately rated receptacles. Eighthly, the role of education and awareness is crucial. End users should be educated about the potential hazards of overloading receptacles and the importance of using appliances safely. Clear labeling of receptacles with their amperage rating can help users make informed decisions about which appliances to plug in. Ninthly, the use of power strips and extension cords should be addressed. Power strips and extension cords can exacerbate the risk of overloading receptacles if they are not properly rated for the connected load. Users should be advised to use power strips with built-in overload protection and to avoid daisy chaining multiple power strips together. Tenthly, regular inspections of the electrical system can help identify potential problems before they become safety hazards. Electrical inspections can reveal damaged wiring, loose connections, and overloaded receptacles. Addressing these issues promptly can prevent electrical fires and other safety incidents. In summary, the decision of whether to use 15-amp receptacles on 20-amp circuits involves careful consideration of the NEC requirements, the potential for overloading receptacles, the role of the installer, and the long-term safety and reliability of the electrical system. While the NEC permits the use of 15-amp receptacles under certain conditions, it is often prudent to use 20-amp receptacles in areas where high-wattage appliances are commonly used. The potential benefits of using 20-amp receptacles include improved safety, reduced risk of code violations, and enhanced reliability of the electrical system. Furthermore, the specific requirements and recommendations for electrical installations can vary depending on the local electrical codes and regulations. It is important to consult with a qualified electrical inspector or engineer to ensure that all installations comply with the applicable codes and standards. Additional considerations should be focused on enhancing clarity and understanding of the relevant NEC sections. For example, NEC section 210.11 C3 specifically addresses bathroom branch circuits, requiring them to be rated at 20 amps and to supply only bathroom receptacles. This section emphasizes the importance of providing adequate capacity for the multiple appliances commonly used in bathrooms. The commentary in the NEC handbook provides additional guidance on the intent of this requirement, noting that it is designed to prevent overloading of bathroom circuits due to the simultaneous use of multiple high-wattage appliances. Another important aspect is the selection of appropriate wiring methods for 20-amp circuits. The NEC specifies the minimum wire size for different ampacities based on the type of conductor and the insulation temperature rating. For example, a 20-amp circuit typically requires 12 American wire gauge copper conductors with a minimum insulation temperature rating of 75 degrees Celsius. Using undersized wiring can lead to overheating and potentially create a fire hazard. The proper installation of receptacles is also critical for safety. Receptacles must be securely mounted in electrical boxes and properly connected to the circuit wiring. Loose connections can cause arcing and overheating, increasing the risk of fire. Receptacles should also be inspected periodically for signs of damage or wear, and replaced if necessary. Furthermore, the NEC includes requirements for the spacing of receptacles in dwelling units. The general rule is that receptacles must be installed so that no point along the floor line of any wall space is more than 6 feet, or 1.8 meters from a receptacle. This requirement is intended to ensure that extension cords are not used excessively, as extension cords can be a source of electrical hazards. The use of tamper-resistant receptacles, or TRRs, is also important, especially in areas where children are present. TRR have internal shutters that prevent the insertion of foreign objects, such as paper clips or toys, into the receptacle slots. TRR are required by the NEC in dwelling units and childcare facilities. The coordination between different components of the electrical system is also essential. For example, the circuit breaker must be properly sized to protect the circuit wiring and the receptacles. If the circuit breaker is too large, it may not trip in the event of an overload, allowing the wiring to overheat and potentially cause a fire. Similarly, if the circuit breaker is too small, it may trip frequently, causing inconvenience and potentially damaging sensitive electronic equipment. The use of surge protective devices, or SPDs, can also help protect electronic equipment from damage caused by voltage surges. SPD are designed to divert excess voltage to ground, preventing it from reaching sensitive equipment. SPD can be installed at the service entrance or at individual branch circuits. In addition to the technical requirements, it is also important to consider the human factors aspects of electrical safety. End users should be educated about the potential hazards of electricity and how to use electrical equipment safely. Clear and concise instructions should be provided with all electrical appliances, and users should be encouraged to read and follow these instructions carefully. Users should also be advised to avoid overloading receptacles and to use extension cords and power strips safely. Regular safety inspections of the electrical system can help identify potential problems before they become safety hazards. These inspections should be performed by qualified electrical professionals who are familiar with the NEC and local electrical codes. The inspectors should check for damaged wiring, loose connections, overloaded receptacles, and other potential hazards. In conclusion, ensuring electrical safety and code compliance requires a comprehensive approach that encompasses technical knowledge, proper installation practices, and user education. While the NEC provides a framework for safe electrical installations, it is important to consult with qualified electrical professionals and to stay informed about the latest codes and standards. By following these guidelines, it is possible to create electrical systems that are both safe and reliable.